Engineering economy. So let's solve problem 6-6. When he started work on his 22nd birthday, D.B. Cooper decided to invest money each month with the objective of becoming a millionaire by the time he reaches age 65. If he expects his investments to yield 18% per annum, compounded monthly, how much should he invest each month? Okay, so he wants to be a millionaire when he becomes 65 years old. And looks like he's around 22 years old. Okay, so the given interest rate is 18%. So we are solving problem number 6-6. The given interest rate is 18% compounded monthly. So which means 1.5% monthly interest rate, okay? Because 18% divided by 12, because there are 12 months in a year, becomes 1.5%. That is the monthly interest rate, okay, that we are going to use. Then what about the interest periods? How many years should be considered? 65 years minus 22 years, right? So how many years is that? That's 43 years, right? So 43 years times 12 months becomes 516 month. That is the interest periods that we are going to use. Okay. So let's draw the cash flow diagram. Here, I'm sorry. Zero, 1, 2, up to 516 months, right? And at the time, he wants to be a millionaire, okay? Then he wants to know how much money he needs to invest each month. So he wants to find uniform annual equivalent uniform annual cost, right? And you're going to use 1.5% monthly interest rate, okay? So here's the situation. So obviously 1 million equals A equivalent uniform annual cost times F given A, 1.5% over 516 period, Okay? So what is this table value? So for the 1.5%, sorry, F given A over 516 periods. But unfortunately, the 1.5% interest table of our text, page number 600, does not contain n equals 516. Okay? But this problem 6-6, must be segmented to use the 1.5% table. Okay? So what I'm going to do is to break down the original cash flow, which is this, into the following two segments. So the first diagram contains the uniform series for the first 480 month period. Okay? So here okay, like this. And the second diagram contains the uniform series for the last 36 month period. 516 minus 480 is 36 periods, right? So let's say 481 through 516. This is the 482, okay, and so on. Let's say this is A prime, A double prime, okay? Sorry, it's very hard to see. So again, this first diagram contains the uniform series for the first 480 month periods, whereas the second diagram contains only the uniform series for the last 36 periods, 36 month period, starting from 481 months through 516 months. Okay? So here if I set f prime, let's say f1 prime, at the end of period 480, then this uniform series for the first 480 month periods can be converted to the equivalent future sum, which is f1 prime. Once we get the value of f1 prime, this single payment or this single amount of money, f1 prime, can be converted to the equivalent future sum of money, which is, let's say, F1 double prime at the end of period 516. Also, this uniform series for the last 36 months period can be converted to the equivalent future sum. Let's say that is F2 double prime. Then this $1 million from the original cash flow diagram, $1 million would be equal to the summation of F1 double prime from here plus F2 double prime here. Okay? Then we should be able to get this uniform annual equivalent uniform annual benefit. Okay? Or uniform equivalent uniform annual cost in this case. So here, how do you get F1 prime? There is going to be A prime times F given A, 1.5% over 480 months, right? 480 months. And we have this table value, right? F given A over 480 period is, let's say, A prime 84,577.8. That's the huge number. And how do you get F1 double prime? F1 double prime is equal to F1 prime, which is this, times F given P, 1.5% over 36 months. Okay? So how much is this? F given P over 36 period is 1.709. This is the 1.709. Okay? Now, how do you get F2 double prime here? F2 double prime is equal to A. Actually, those A's are identical, right? So let's use A prime. Or, okay. And F given A, 1.5% over 36 months. Okay? What is this value? F given A over 36 period. 47.276. 47 point, sorry, I've given A 47.276. 276. So down here, the $1 million should be equal to F1 double prime, which is this. So here we have A prime 84,577.8 times 1.709 plus F2 double prime, which is this. So A prime times 47.276. That is equal to 1 million. Okay. So here we have only one unknown variable, which is a prime. So you should be able to get the value of a prime by solving this equation. Okay. So here a prime, or equivalent uniform annual cost, would be how much? Okay, so this is the $6.92. That is the monthly investment. If you want to be a millionaire when he becomes 65 years old. Okay? Okay, then the next problem that we are going to solve is problem number 6-11. A firm is about to begin pilot plant operation on a process it has developed. One item of optional equipment that could be obtained is a heat exchanger unit. The company finds that a unit now available for $30,000 could be used in other company operations. It is estimated that the heat exchanger unit will be worth $35,000 at the end of 8 years. This seemingly high service value is due primarily to the fact that the $30,000 purchase price is really a rare bargain. If the firm believes 15% is an appropriate rate of return, what annual benefit is needed to justify the purchase of the heat exchanger unit? Okay, so as usual, let's draw the cash flow diagram first. So we are working on problem number 6-11. So the purchase price is $30,000. Zero, 1, 2, 3, up to year 8, right? And so we want to know the annual benefit for the next 8 years. So we want to know annual benefit here. And at the end of year 8, there is a service values of $35,000, or is worth at $35,000 at the end of year 8. So you need to put 35,000. Okay. So here, obviously we can see that equivalent uniform annual cost, which is $30,000, is equal to the equivalent uniform annual benefit, which is from this positive cash flow. Okay. So if we solve this equation, then you should be able to get this uniform annual benefit. Okay? So here, equivalent uniform annual cost is simply 30,000 times A given P. And we are using 15% of interest rate. So 15% over A period is equal to A's, right? Plus the $35,000 at the end of period A. So you need to convert it to the equivalent uniform annual benefit, which is A given F 15% over A periods. Okay? So 15% interest rate table can be found in page number 615 of our text. A given P over A period is 0.2229. What about this? A given F over A period is 0.0729. So how much is the annual benefit in this case? Okay, this is going to be $4,135.50. Okay, so that's going to be the annual benefit. Okay, next, let's solve problem 6-12. A firm purchased some equipment at a very favorable price of $30,000. The equipment resulted in an annual net saving of $1,000 per year during the 8 years it was used. At the end of 8 years, the equipment was sold for $40,000. Really? Okay. Let me just double check. Okay. Because the resale value is a lot higher than the original purchase price, which is very unusual. So I just want to make sure whether I got this correct values here. Okay, and assuming interest at 8%, Did the equipment purchase prove to be desirable? Okay. So this is the problem number 6-12. So here we can get the equivalent uniform annual cost. That's going to be $30,000, the purchase price. This will be converted to the equivalent uniform series. So A given P times 8% of interest rate over 8 years minus $1,000, because this is the net saving. This is your benefit. So it's going to be negative $1,000. Okay? And at the end of 8 years, the equipment was sold for $40,000. So negative $40,000. Also, this amount of money should be converted to the equivalent uniform series. So A given F, 8% over a period. Okay. So what is this value? A given P, 8% over a period. That is 0.1740. 0.1740. What about this? A given F over a period is 0.0940. 0.0940. So how much is for the equivalent uniform annual cost? So here we have $460. So the equipment has an annual cost that is $460 greater than the benefit. So the equipment purchased did not turn out to be desirable. Okay? Okay, so next problem that we are going to solve is problem number 6-24. Okay. A motorcycle is for sale for $2,600, and the motorcycle dealer is willing to sell it on the following term. No down payment, pay $44 at the end of each of the first 4 months, and pay $84 at the end of each month after that until the loan has been paid in full. Based on these terms and a 12% annual interest rate compounded monthly, how many 84 payments will be required? So here we are solving problem number 6-24. Here the given interest rate is 12% compounded monthly. Which means 1% monthly interest rate. Because 12% divided by 12, because there are 12 months in a year. So we have 1% monthly interest rate. Okay? That's we are going to use. And let's draw the cash flow diagram to visualize the situation that we have. So the motorcycle is for sale for $2,600. Okay. And no down payment, and pay $44 at the end of each of the first 4 months. 1, 2, 3, 4. So we have $44. 0, 1, 2, 3, 4. And then after that, at the end of each month, the monthly payment go up to $84, right? And we don't know how many $84 payments will be required. So let's put n up here. Okay? So 5, 6, 7, 8, up to certain number n. Okay? So now let's compute the equivalent future sum for the $2,600 and the 44 payments at F at the end of period 4. So let's say we have F up here. Okay? Then how would you get this equivalent future sum for $2,600 and this 44 payments? 2,600 times F given P, 1% over 4 period, and minus, right? 44 F given A, 1% over 4 periods. Okay? So how much is these values. 1%, F given P over 4 periods is 1.041. This is 1.041. F given A over 4 periods is 4.060. 4.060. Okay? Then how much is this? Okay, this is $2,527.96. Okay, and this is the amount of money still owed at the end of the 4th month, right? That is, this uniform series of $84 can be converted to the equivalent sum of money, which is F. Is that correct? So now, if I say we have N here, then we could solve for this unknown value of N as follows. So here we have 2,527. Oh, sorry, $2,527.96 is equal to $84, and P given A 1% over N periods. Okay? So here P given A 1% over N periods is equal to 2,527 over 27.96 over 84. What is this value? That is almost 30.09. Okay? And from the 1% interest table, which is provided in page number 598 of our text, N value, the value of N is almost 36. Okay? So we can say that 36 payments of $84 will be required. Okay? So this is the answer for problem number 6-24. Okay. Okay, next problem that we're going to solve is problem number 6-21. Okay, for the diagram, compute the value C that result in net equivalent annual worth of 0. Okay, and we are using 10% of interest rate. Let me redraw the cash flow diagram. This is problem number 6-21. So there are 5 periods. Zero, 1, 2, 3, 4, and 5. And at the end of period 1, there is a positive cash flow of 40. At the end of period 2, 30. At the end of period 3, 20. At the end of period 4 and 5, 10. Okay? And we are using 10% of interest rate. And here we have negative cash flow of C's at the end of period 2, 3, 4, and 5, right? Those are C, value of C. Okay, so what I'm going to do is to convert these positive cash flows to an equivalent present sum, let's say X here, at the end of period 1. Okay? And then convert X to an equivalent uniform series of C's. Okay? And here, the positive cash flows, these positive cash flows can be broken down to the following 4 components. Positive cash flows can be broken down to 40 plus uniform series of 10 for the next 4 periods plus $20 over 1 period say this is P1, P2, P3, and then last component, which is this P4, 1, 2, 3. There's 10 down here. Okay? So these positive cash flows can be broken down to these 4 components. Okay? So obviously x can be obtained by summation of P1, P2, P3, P4, right? So P1, P2, P3, and P4, okay? So how'd you get P1? It's just 40, right? How about P2? Ten times P given A, 10% over 4 periods, right? What about P3? You can just convert this single payment to the equivalent present sum. So 20 times P given F, 10% over 1 period. How about P4? 10 times P given F, 10% over 2 periods. Is that right? And 10% P given A over 4 periods is 3.17. This is this 3.17. How about this? P given F over 1 period is 0.9091. 0.9091. How about this? 0.8264. 0.8264. Okay. Then what is the value of x at the end of period 1? This is going to be $98.15. Okay. Now we're going to convert this x value to an equivalent uniform series of C, the original cash flow diagram. Okay. So now convert x to an equivalent uniform series of C. Okay. So here C is equal to 98.15. So I will show you the original diagram. And times A given P 10% over 4 periods, right? So A given P 10% over 4 periods. What is this value? A given P over 4 periods, 0.3155. This is the 0.3155. Okay. So how much is that? It's going to be $30.97. So in this original diagram, the value of C's would be $30.97. Okay. So, as many of you already noticed, in this problem we've used the criterion EUAW, which is equivalent uniform annual worth, that can be calculated by equivalent uniform annual benefit minus equivalent uniform annual cost is equal to 0, right? So we have used this criterion for solving problem 6-21. Okay. Okay. Then next problem that I'm going to solve is problem 6-23. Okay, the maintenance foreman of a plant, in reviewing his records, found the maintenance foreman of a plant, in reviewing his records, found that a large press had the following maintenance cost records. And after consulting with a lubrication specialist, he changed the preventive maintenance schedule. He believes that this year maintenance will be $900 and will decrease $100 a year in each of the following 4 years. If his estimate of the future is correct, what will be the equivalent uniform annual maintenance cost for the 10-year period? Assume that the interest rate is 8%. Okay? Okay, so let's visualize our situation by drawing the cash flow diagram. Okay, so we are working on problem number 6-23. So here, starting from 5 years ago, right? So let's put -5. There is a $600. So I'm going to put here 600. And 4 years ago, just put some here. 3, 2, 1, 0. 1, 2, 3, 4. Okay, something like that. 3, 1, 0, 1, 2, 3, 4. And then 4 years ago becomes 700. 3 years ago, 800. 2 years ago, 900. Last year it was $1,000. Okay. Okay. And then he believes this year maintenance will be $900, and then will decrease $100 a year in each of the following 4 years. So this year it's going to be $900, and then decrease $100 a year in each of the following 4 years, right? So we have 800, 700, and 600, and 500, like this. Okay. And we want to find the equivalent uniform annual maintenance cost for this 10-year period. Okay? So we want to find uniform annual maintenance cost over the 10 periods. So EUAC, we want to know this. We are using 8% of interest rate. Okay? So this is the situation that we faced currently. So, of course, there are several different ways to obtain the equivalent uniform annual maintenance cost. And what I'm going to do is to convert this positive cash flow to the present worth of cost at time -6. Okay? So I'm going to put here okay, whatever here, let's put P. Okay, so I'm going to convert all of these positive cash flows to the equivalent present worth of cost at time -0. Okay, and then convert this P to the equivalent uniform annual maintenance cost. Okay, and first this positive cash flow can be broken into 2 components. So the first component has the increasing gradient of 600, 700, 800, 900, 1000. Okay, and then second component is about decreasing component. Okay, So we have 900, 800, 700, 600, and 500. Okay? Negative 6, 5, 4, 3, 2, 1. And negative, no, this is 0, 1, 2, 3, and 4. Okay? So this positive cash flow can be broken into these two components. Okay? So if I said the P sub negative 6 right here, and let's say Q negative 6, and also if I said Q negative 1, okay, at the end of period negative 1, like this. Then the equivalent uniform annual maintenance cost, EUAC, can be calculated by P sub negative 6 plus Q sub negative 6, right? Times A given P, 8% over 10 period. Is that correct? Of course, Q sub negative 6 can be obtained by converting Q sub negative 1 to the equivalent present sum of money, right? Times P given F, 8% over 5 periods. Negative 6 through negative 1 as 5 periods. Okay? So first, how to compute, how to calculate P sub negative 6 up here. P sub negative 6. Here, the period by period change amount is 100. Okay? So this cash flow can be broken down to the uniform series of 600 plus the arithmetic gradient series of 100. Okay? So this is going to be 600 P given A, 8% over 5 period plus arithmetic gradient of 100 times P given G, 8% over 5 periods. Is that right? Now, how about Q sub negative 6? So in order to compute q sub negative 6, first we need to compute the q sub negative 1, right? Once we get the q sub negative 1, we can convert it to the equivalent present sum, which is q sub negative 6, okay? So here, q sub negative 1 is again the summation of uniform series of 900 minus arithmetic gradient series of negative 100, right? So 900 times p given a, 8% over 5 periods, minus 100 times p given g, 8% over 5 periods. Okay. So once you get q sub negative 1, you can get q sub negative 6, which is q sub negative 1 times p given f, 8% over 5 periods. So, oh, we didn't get p sub negative 6 yet. So p given a, 8%. Over 5 period is 3.993. And p given g over 5 period is 7.372. So what is the value of p sub negative 6? That is $3,133. Okay. Now go back to q sub negative 1. Here p given a over 5 period is 3.993. So this value is 3.993. P given g over 5 period is 7.372. 7.372. And P given F over 5 period is 0.6806. 0.6806. Okay. So here q sub negative 1 is $2,856.50. And q sub negative 6 would be $1,944.13. Okay. So if we go back to this formula that we've written down earlier, P sub negative 6 is 3,133. Q sub negative 6 is $1,944.13. And what about this A given P over 10 periods? That is 0.1490. This is the 0.1490 times 0.1490. So how much is this? Okay, this is $756.49. Okay. So this is the equivalent uniform annual maintenance cost for the 10-year period, which is this. Okay. Okay, so I'm going to stop here for today. And looks like we're going to spend another hour to solve end of chapter 6 problems. Okay, thank you very much. I will see you next time. Bye.